So here, if you divide this word into parts, we can observe here one word as poly, another word as morphism. You know the meaning of morphing. Morphing means changing, changing. Okay, fine. Poly means minimum. Polynomial expression antam kada, many form, many many kind of exponentials. So similarly, poly means many, morphism means forms, changing. So totally, if you combine the word, we can say it is many forms, meaning that if you are going to represent one form in many forms, one form in many alternate other forms, we can call it as a polymorphism. Okay, like for example, Amma, I have a method, one method. That method I am going to represent in many forms. Many forms. We can say that it is a kind of polymorphism. For example, Amma, uh, uh, student is there. Student is there. I mean, I won't call it as a student. There is a person. There is a person. Okay, he is a student for me in my college in Arjukit SQL. In Arjukit SQL. I mean, he is a boy. He's a boy. This boy is a student in Arjukit SQL. This boy is a son in the home. In the home. And this boy is an audience at somewhere theater, or this boy is a player at somewhere stadium, meaning that there exists one physical form. There exists one physical form. This physical form act in different ways. At sometimes he act as a student, he act as a son, he act as an audience, he act as a player. So depending upon the type of location, he will change its properties. Its properties. Okay. Similarly, for example, there is a man. There is a man. There is a man. He acted as a son for his father. For his father. He something like he acted as a husband also at sometimes. He acted as an employee at working locations. Like this, right? Is the one kind of form. That form can be in many forms. Like for example, there is a pen. There is a pen. Okay, assume that it is a kind of pen. Okay, okay, there is a pen. This pen can act as a red color at sometimes, can act as a blue pen at sometimes, can act as a green pen at sometimes, can act as a some other color, black color at sometimes, right? Yes. Depending upon the type, it is going to change its form. But the actual form is a normal pen. Actual form is a normal pen, right? Meaning that here there are some characteristics for the pen. Those characteristics are applicable to red, blue, green, and black. There are some characteristics for boy. Those characters will applicable to student, son, audience, and a player. Those are all characters directly. Man, these characters are applicable to son, husband, and an employee. Son and employee. Okay. Here, one form means that actual form. That is a original form. Original form, meaning that it's a kind of original method. Original method. And many forms, meaning that, see, guys, there is some kind of method. There is some kind of method. Like, let us assume that some method is there. Some method is there, right? So this some method I can able to write in many forms. I can able to write in many forms, right? While seeing the concept of methods, I said there are two types of methods. One is overloaded methods. Overloaded methods. Another one is overriding methods. Overriding methods, right? Overloaded methods means method name is same, method name is same, but its signature is different. It is accepting two parameters, sum int a. Method name is same, it is accepting one parameter. Method name is same, it is accepting two parameters, but those two parameters are different. So these are all called overloaded methods. Overloaded methods. And there is one more form. If you are going to apply the concept of inheritance, what will happen? This sum method will be inherited to the superclass. See, one kind of form is the methods. One kind of form is a overloaded form. One kind of form is a overridden form. Overridden form, right? Overloaded means method name is same, but whose signature is different. That you know already, meaning of signature. In overridden form, when you are going to override in the same class, like for example, class A, in the same class, I can't able to write a method with same name and same number of parameters. So meaning that in the same class, I can't able to override the same thing. I can't able to override the same thing. But if you go for applying the concept of inheritance, like extends A, you know, this sum method is available here logically. If you want, you can override that sum method. You can override that sum method. Okay, fine. So what I will do, I will write like sum. So what you can observe here, the same method, the same one original method, which is modifying its forms or not, which is modifying its forms in the form of overload methods. Here, the same method is modifying its body here or not. Yes, that reference one form, in many forms. In many forms, you can achieve it through overload methods, and you can achieve it through overridden methods. Okay, fine. So guys, here, so I hope you understood the clear meaning of polymorphism. Polymorphism means one form will exist in many forms. Based upon type of type of method you are using, it is classified into two types. One is static polymorphism. Static polymorphism. Okay. So another one is we can call it as dynamic polymorphism. Dynamic polymorphism. So in static polymorphism, the best example for static polymorphism is overloading. Overloading is the best example for static polymorphism, and for dynamic polymorphism, overriding is an example. Okay. So what do you mean by static polymorphism? You know, uh, see, there exists a method. There exists a method in a class. There exists a method in a class. That method, and there are multiple remaining methods are there. Method name is having same name, but it's having a different signature. It's having a different signature. Then, see, I will write a class. I will write a class A. Class A. There is some method void m method, and there is some method void uh, m method, which is taking two parameters int a comma int b, and there are some method void m method. It is accepting one single parameter. Guys, I will make a program driver. I'll make a program driver, and I am going to create an object for this. A equal to new A. If I am going to call a dot m of 5, can you decide on your own or not? Can you decide on your own or not? Whether it is going to execute which method? It is going to execute this method. If I am calling like a dot m of 5 comma 6, it is going to execute which method? Which is accepting two parameters. If I am writing like a dot m, it is going to execute which method? This method. Meaning that, so you are going to decide which method is going to execute. That decision is during at which time? It is going to take at compile time. It is going to take at compile time. Meaning that uh, during the compilation phase itself, during the compilation phase itself, compiler decides compiler decides which method should be invoked. Which method should be invoked. So then we can call it as a static polymorphism. Meaning that these overload methods binds with an object at what time? Compile time. What time? Compile time. Then we can call it as static polymorphism, or or we can call it as compile time polymorphism, or we can call it as static method dispatcher. We call it as static method dispatch, meaning that dispatching a method at compile time. We call it as static method dispatch, meaning that I won't get any kind of confusion. I won't get any kind of confusion. So this is what all about the meaning of static polymorphism. See, there are multiple forms are there. Among those all forms, compiler will determine which method need to execute at compile time itself. At compile time itself. Okay. So during the compilation process, the calling function decides one method, and during the runtime itself, the calling function will call the same method. Then we call it as static polymorphism. I hope you understood. At compile time, whatever the method it is calling, if at runtime, whatever the same method if it calls, then we call it as a static polymorphism. Static polymorphism. Okay, fine. So now let's see an example for that. Okay. I have taken some base class, and here I have created an object. Okay, fine. Let me remove this. I'm going to take system.out.println of main method starts execution. Starts execution. Okay. So here I'm going to take one method, void m method. Base class without parameters. Here I'm calling int a, base class with single parameter. Here I'm calling one minute. Here I'm calling base class with double parameter, with single parameter with double parameter. Okay, I have saved this one, and I'm trying to call these all are instant method I can able to call with respect to base class object. So how to create base class object? BC from B equal to new BC. Okay, fine. So now I'm going to call B dot M. What we can do during the compilation process? It is going to check for the corresponding M method is there or not, which is taking which is taken without any parameters. Yes, there exists. But during runtime also, the same method is going to get. The same method is going to call. So it is called static polymorphism, meaning that during compiling time itself, it is going to decide which method is going to run at runtime. Okay, fine. I'm going to call b dot m of I'm passing like 5. Now it will decide uh, which method is called b dot m of 5 comma 5.5. 5 point. Okay. Now I'm going to compile this. Compile this. See. So during the comparison process itself, it decides which method it needs to call. Java C space x overload dot Java. It may take time for the first time, right? Right. See what happened? Incompatible types, meaning that there is a possibility logic conversion from double to float. Yes, right. So you are writing without any prefix means you are going to get it as a double. So if you write like f, it is going to consider it as float. Java space as overload. You are getting the answer. Yes. BC with parameters, single parameter, double parameter. So this is the concept of uh, static polymorphism, meaning that during the compilation process, it is going to decide which method it needs to call. Okay. Coming to dynamic polymorphism, this you can achieve it through the concept of uh, overriding. Overriding. Okay. Overriding, when we are going to perform overriding process, it is going to do at the time of inheritance. Time of inheritance. Okay, fine. So to explain this dynamic polymorphism concept, first let me go for explaining one more concept, that is dynamic method dispatch, or we can call it as dynamic binding. Dynamic binding. So what we are going to do in dynamic method dispatch means so generally there is some class A, there is some class A, and there is some class B, which is extending class A, which is extending class A, and there is some method void m method. This method is going to, if you want, you can override here also. This is A method and this is a B method. B method. Okay. So here, what the dynamic method dispatch is saying that, see here it is a kind of concept. It's not a principle. So this dynamic method dispatch, what it is going to do is uh, here, whatever the overridden method is there, whatever the overridden method is there, that overridden method, which overridden method I am going to call, is going to decide at runtime. Is going to decide at runtime, meaning that it's a kind of mechanism. It's a kind of mechanism in which call to a overridden method, call to a overridden method is decided at runtime. Is decided at runtime. Then we can call it as dynamic method dispatch. This is a concept. Call to a overridden method. So, like for example, there is a some class C extends class A, extends class A. Again, I am overriding void m. I'm overriding void m. See here, what I will do, if I create an object, see guys, observe carefully. If I create an object small c for class C, for class C, if I create an object, if I am going to call c dot m, then we can able to decide this method is calling. This method is called. If I create an object for class B, if I call with respect to B, then I can decide this method is calling. If I create an object for class A and I am calling with respect to object A, then I can decide that this method is calling. This method is called. But what it is saying that you have to call a overridden method is decided at what time? Runtime. Is decided runtime. But if you go for this process, what will happen? The compiler decides during the compilation process whether I am going to call this m method or this m method or this m method. It decided compile time. That's it. Okay, fine. I don't want like that. I want to decide this at during during runtime. During runtime. So then, what this dynamic binding saying that? So to achieve this concept, what we need to do is uh, we don't want to create. See, in the previous classes, what I said, create an object for bottommost classes, so that memory will be allocated for all the topmost classes, and it starts executing from topmost method. But constructors are calling from bottom to top. Bottom to top. I said, I mean, create an object for bottommost classes, so that memory will be allocated for all time, for everything. Neural grid for everything. But what the dynamic method dispatch is saying that don't create object for derived classes. Don't create object for derived classes, but instead create object for base class. Create object for base class, so that through this base class I can able to refer this derived class methods or not. Yes, I can able to refer. I mean, so how you can do this one? See, this you can achieve through the concept of typecasting. See here. So I can able to create an object for base class or not. I can able to create an object for base class. For that base class, I can able to assign an object of derived class. Able to assign an object of derived class. See here. What we are going to do is so to make this, here they are saying that don't create an object for derived class, but create an object for base class. So how we are going to create an object for base class? I can able to create an object for base class as A, and I am making it as object reference as A. Object reference as A. And for this A, I mean for this superclass object A, I am going to assign a derived class object like B, like lib B. So it is valid or not? According to object typecasting, it is valid because subclass object I can able to assign it to superclass object. So what is this object B? B is an object which is related to class B. So I'm going to create an object first B equal to new B. Yes. So that I can able to now what will happen? The reference of B is copied to where? A. The reference of B is copied to A. See, I have said there one thing. I said once we assign a subclass object, assign it to a superclass object, subclass overridden methods will be called, we can call with respect to a superclass object. Subclass overridden methods will be called with respect to a superclass object. Here, if I write like this, meaning that through this superclass object, I can able to refer a subclass method, or I can able to refer a superclass method. Meaning that if I write like a dot m, I can able to call this method. So for example, if this m method is not exist, then it can able to call this m method. That is the concept of dynamic method dispatch. So here, what will happen is whenever you write like this, uh, so it is going to decide it is going to decide which method. See, for class A, for the object A is having one method m, for object B is having one method m. Then this kind of reference is going to decide during runtime only. Meaning that when a overridden method, see a dot m, when an overridden method is called through a superclass reference, then the Java compiler decides which version of the method, whether I want to call this method or I want to call this method, is decides based upon the type of object being referred. Based upon type of object being referred, here the type of object being referred is B object, and this also decides during at runtime. This also decides during at runtime. So this concept we call it as a dynamic method dispatch. Okay, fine. See here now, what I will do is for the same A, I will create an object of B. See, for C new C, new C. Then if I write like this, what is the meaning of this one? This is a subclass object. This is a superclass object. It is a valid. It can perform implicit object type caching. There is no error. If I am going to call a.m, then it will execute this method. Meaning that when different types of objects are referred, through a superclass reference, then different versions of the methods will be executed at runtime. This concept we call it as dynamic binding or dynamic method dispatch. See, let me take an example for this. I will take class A. I am simply taking M. Okay, I will take class A directly. Class A, no idea. I'm going to copy this same thing. Make class B, which is extending class A. And I'm going to make copy the class C, which is extends class A. But in all the things, the method name is same. Now what I'm going to do is I'm going to create an object for all the classes. First a equal to new a, then b equal to new b, c equal to new c. Okay, now see, if I call like normally a dot m, it is going to call this method. If I call b dot b, b dot m, it is going to call this method. If I call like c dot m, it is going to call this method. But I don't want like that. If I write like this, see, a dot m or b dot m, or I will call like c dot m. So for all these, what will happen? It is going to decide during the compilation itself whether I want to call which m method. It is going to decide during the compilation. For example, if I make like this, for a superclass object, I am going to assign a subclass object. Then we can say that here dynamic method dispatch concept is applied. Meaning that how the compiler will get an ambiguity means, if I like a.m, here the compiler will get an ambiguity. See, in the both a class object and in the both b class object, there is an m method. Then compiler won't decide during the compilation process, and it will decide only during at runtime. So now you are going to get the answer as BC without parameters. All are same. Huh? This is B class. A class, and this is C class. Okay, na? Fine. Java space yes overload. See what happened? B class is called. For example, I have removed this one. I have removed this one. Just see what happened. I have referred it to 1 minute. I am going to check. B. I have removed this one. Then you are going to get that A class. You are going to get as A class. Okay, fine. A class. Here, so for example, okay, fine. Like if I am calling like something, same A equal to, I'm making it as C equal to C. I'm making it as C. Now if I like this, A dot M, will get as a C class, B class as well as C class, B class as well as C class. Okay, now meaning that here the reference of B is copied to A object. Similarly, A is referred to C object. So this is the concept of dynamic method dispatch. Okay, fine. So generally, so while uh, while implementing the concept of dynamic polymorphism, we will use the concept of dynamic method dispatch or dynamic binding. I mean, to implement the concept of dynamic polymorphism, internally we will use the concept of dynamic binding. Okay. So generally, why we are going for overridden methods? First thing, see, the concept of polymorphism is there is a some general class. There is a some general class, something like class A, something like class A. So this general class will specify all the methods, all the methods that are common to all of its derivatives, that are common to all of its derivatives, all of its derivatives. Okay, something like class C extends class A, meaning that if this class B wants to override the methods which are defined by class A, then it can override. There is no problem at all. So this is one way of why we are moving for overriding. So through this overriding concept, we can able to achieve runtime polymorphism, or we can call it as a dynamic polymorphism. So how we are going to achieve? Meaning that the same thing. What we are going to do? We are going to apply the concept of dynamic binding. So I can say the definition for runtime polymorphism, meaning that if we call a overridden method on the superclass reference, then the subclass method will be called. And it is going to decide at what time? It is going to decide at runtime. It is going to decide at runtime. Then we call it as runtime polymorphism. I hope you understood. So to achieve the concept of runtime polymorphism, we will use the concept of dynamic binding. What is meant by dynamic binding? To get to call a overridden method, we are going to call with respect to an object of superclass. Then that which method is going to call is decided at runtime. Then we can call it as a runtime polymorphism. We call it as runtime polymorphism. Okay, fine. So this is the concept of runtime polymorphism. Okay, fine. Okay. See, generally, you'll have one thing. Uh, See, generally, what we are going to do is you are going to write something like this. So the same example I am going to write here, uh, class A, or I will take this directly. Class A, class B, class C. Here what we are going to do, we are having a sum method. Here also let us assume that there is a sum method. Here also there is a sum method. And I am going to create an object for base class first. I'm going to create an object for base class. Base class A equal to new A. For this base class object, I'm going to refer the derived class object. The derived class. How we are going to refer the derived class object? I can derive like this, right? New B. Right. Now if I call like A dot sum, it is going to call with which method? This method is going to call. Similarly, if I write like A equal to new C, if I write like A dot sum, meaning that the same object is going to use for to call all the overridden methods. This is called runtime polymorphism. Runtime polymorphism. Okay. Here the object A. Here the object A. Uh, this object, we call it as a runtime object, or we can call it as a polymorphic object. A polymorphic object. And here the method sum is what it is. It is existing for multiple forms in a overridden format. So we can call it as polymorphic method. Polymorphic method. And this statement, whatever statement that we are writing, this statement, these statements we will call it as polymorphic statements. Polymorphic statements. Okay, fine. So what we discussed here, I mean, simply polymorphism means it's a kind of two types. One is static, another one is dynamic. In static, overloading is done during a overloading concept is decided during compile time. Whereas coming to dynamic polymorphism, we are going to decide during at runtime. During at runtime, that runtime, how we are getting that runtime is because of applying the concept of dynamic method dispatch. See, general gamma in the real world, in the industries, we'll have three variations of implementing a program. Okay, generally, something like there are multiple base classes. I said already, right? Base class one, base class one, and base class two. Sorry, I should not write like this, right? I should not write the parameters. Base class 1 is a class, base class 2 is a class, base class 3 is a class, and so on. Base class n is a class, and there is one execution class. There is one execution class. Yes. So all these base classes are independent, right? All these base classes are independent. Similarly, this execution logic class is not following any principles. It is also independent. This is one way we can write. Similarly, there are some concepts which we apply inheritance concept. Base class 1, base class 2, which is extending base class 1. This is one principle. Base class 3, which is extending base class 2. This is one and so on. And there exists one class, that is execution class. This is normal follow, meaning that here there are multiple dependent classes, and there is one execution class. This execution class, we are following normal process. Then at this time, normal process means what we are going to do? We are applying the concept of overriding, and and we are applying the principle of polymorphism or not? We can apply the principle of polymorphism. See, polymorphism ante enti? Whatever the methods that we are defining in the base class, that is a general class that is applied for all the classes. So because of those are all overriding, we are getting as overriding concept. See, I am thinking that you are not getting. See, polymorphism means there is a general class. There is a class which is base class. In that base class, we are going to define all the methods which are required for the program, and we are going to override wherever necessary. We are going to override wherever necessary. This is a polymorphism, and we are applying overriding. Yes, overriding is getting because of the concept of inheritance. Okay, here what we are going to do in the normal process, we are going to create an object for derived classes. We are going to create an object for bottommost derived class. Observe, I said this is also bottommost derived class. And once I create an object for bottommost derived class, then memory will be created for all the classes, and it is going to call during the, it is going to decide that during the compilation phase itself. During the compilation phase. Yeah. So in this process, there is no concept of overriding. As there is no concept of overriding, we have to write the same method here also, here also, here also, if it is necessary. So in these two cases, memory space is occupying the memory space is more, and also it will take more execution time. Because of more execution time, it is going to perform less performance. Okay, to overcome these two methods, what we are going to do is we are going to apply the concept of polymorphism. And as we are applying polymorphism, if it requires, we can override it. And also we need to apply dynamic binding, or we can call it a dynamic method dispatch. See, what do you mean polymorphism? See, in class, whatever the methods are there in general class, those are all will be dependent for the coming classes. I mean, there is a dependency between all the classes. Yes, this is a kind of dependency. And what are the method that we are writing here? It is overriding. Okay, so generally in the previous step, what we did, we have gone for normal process, but here I recommend you to use, in the execution class, I recommended you to use the concept of dynamic method dispatch. Dynamic method dispatch means create an object for base class, and assign the subclass object to a superclass, so that during the runtime it is going to call which method it should be called. It is going to decide. So that because of this process, because of applying this dynamic method dispatch, these problems will be rectified. What are those problems? Memory space will be less or not. See, the occupying the memory space will be reduced, and execution time also reduces, and the performance will be increased. So final conclusion is, go wherever you are going to write a program, go for the concept of inheritance, so that automatically you will get a concept of overriding. And along with that, in the execution class, if you apply dynamic binding principle, then obviously it is going to take less memory space, and it will take execution time less execution, and it is going to get more performance. See, up to now, up to previous class, we have seen polymorphism and overridden, but we didn't apply the concept of dynamic binding. Now, if you apply the concept of dynamic binding, we'll enhance all these features. Okay, fine. So this is for today's class, and if you have any doubt, you can ask.